Hello everyone. Today's lecture is on fractions. I hope you all enjoyed the first lecture that was on basic arithmetic concepts. Today's lecture would a bit build up on the work we did last time, but mostly it will be introducing new concepts. Alright, so let's get started. So first of all, what are fractions? Well, fractions, some of you, probably a lot of you have already seen them. They look like something like this. So you have an integer, let's say 5, then you have this bar, and below that you have another integer. So two numbers and you have this bar in between. This is called a fraction. Terminology wise, okay, instead of having a 5 here, let's just have a 7 here. Okay, terminology wise, the numerator or the number at the top is known as a numerator, and the number on the bottom is known as a denominator. Okay. So to think about fractions in practical terms, think of a pizza. Okay, and let's divide this pizza into some parts. So this one has 1, 2, 3, 4, 5, 6 slices. So let's say someone eats two of these slices. Alright, or let's say Sohail eats 2 of these slices. So the way to write this in fractions would be, okay, Sohail ate 2 out of 6. Okay, so that's how in fractions you will show that Sohail ate two of the 6 slices of the pizza. This actually can be simplified a bit, but we'll talk about that a bit later. In words, this is written as 2/6. Okay, so I would say I ate, or Sohail ate 2/6 of the pizza. Okay. Similarly, let's say someone ate 1 slice. So 1 slice out of 6. So that the way to write that would be someone ate 1/6 of the pizza. So the numerator shows up as a regular number, and the denominator you use these suffixes like th, or similarly others for other numbers. Okay. So fractions can be converted to decimals, and you can use your calculator to do this. So fractions can go to decimals. So let's look at some of the common fractions that you'll encounter on GRE. So first of all, the easiest one, 1/2, 1/2. Okay, so you put this on your calculator, you'll get to 0.5. Next, 1/3. So this would give you 0.666, and this will continue on to infinity. Next is 2/3. Oops, sorry. So 1/3 is not 0.666, it is 0.333 onwards. 2/3 is 0.666 to infinity. Okay. If you go to 3/3, what will you get? Well, that's just 1. Okay. Moving on to fraction with denominators of 4. So 1/4, that's 0.25. This is also known as a quarter. So whenever you hear a word quarter, it means you're referring one part out of 4. So if you have 4 slices of pizza and you ate 1, well, you ate a quarter of a pizza. Okay. And the fraction with the 4 in the denominator, 3/4, 0.75. This in words would be called 3/4. So it's just basically I have quarters, but I have 3 of those, right? Going to a fraction with denominators of 5. So 1/5 is 0.2. 2/5 is double of that, 0.4. 3/5 is triple of 0.2, 0.6. 3 times 0.2. Then 4/5 is 0.8, right? So these are the ones that I would recommend that you memorize. So this would really help you in becoming quick on doing these GRE problems. You don't want to use the calculator for these ones. So memorize. Okay. Moving on. So let's say, so up till now we have seen fractions where the numerator, the top number, was less than the bottom number. So in this case, the result, if you do the division on the calculator, is always less than 1. Okay. What if the numerator is greater than your denominator? So let's say 6/5. So in this case, the decimal value would always be greater than 1. So whenever your numerator is greater than the denominator, your value is greater than 1. This would help when you are doing GRE problems when only a comparison is enough to answer a question. It's greater than 1. Okay. Also, when the numerator is greater than the denominator, you can rearrange the fraction in an interesting way. So let's look at an example of that. So let's say we have 15/2, right? Now if I do the division, the actual division here, so 15 goes in here, 2, I'm dividing 15 by 2, 2 times 7 is 14, right? That will give me a remainder of 1. So I can actually rewrite this fraction as something like this. So the quotient, remember the quotient from last lecture? The quotient of this division comes here in front. The remainder goes here as the numerator, and the actual divisor, the number that was dividing 15, that goes here in the denominator. This is known as a mixed fraction. Okay. Again, your quotient comes in the front, the remainder as a numerator of the mixed fraction, and the divider as the denominator for the mixed fraction. Now if you have a mixed fraction, you can go back to your original fraction this way. So you can times your quotient by the divider. So 7 times 2 is 14. Add the remainder to it. So add 1 to it, which was the remainder, and again divide by 2. So this will give you 14 plus 1, 15/2. Okay. Let's do one more. So let's do 13/6. Okay, so let's do the long division. 13 divided by 6. So 6 times 2 is 12. The remainder comes 1. So in this case, this fraction in mixed fraction terms would be your quotient 2, the remainder 1 over the original divider 6. Okay. Again, to go back from the mixed fraction to the original fraction, you do 6 times 2, 12, plus the remainder 1 over 6, which is 13/6, the original fraction that we had. Alright, moving on to the next concept. So last time we looked at some number quantities, right? Number categories. Today we'll do one more category, which is not that crucial for you to know for the GRE, but still important enough that you should be aware of. So this category is of rational numbers. Rational numbers, and the opposite of that, irrational numbers. So the fractions that we looked at till this point, let's look at them again. So let's take your 1/2, which was 0.5, right? Let's take your 2/3, which was 0.666, which actually can be represented, since 6 repeats for infinity, you can represent it by just writing 1/6 and with this bar at the top. Again, not that critical to know for GREs, but still. Let's look at it. And then how about this one, 3 over 11? This actually in decimals would give you this repeating pattern of 2 7 2 7 2 7 continue on. So this in shorthand would be denoted by 0.27 with this bar, right? So any number that can be represented as a fraction comes under rational numbers. Okay, numbers that can be represented as fractions, these are irrational numbers. Okay, so then you should have numbers that cannot be represented as fractions, and these are your irrational numbers. So numbers such as root 2, which is a very common root you'll see on GREs, and actually you should memorize the value in decimal for root 2. 1.414, see, 1.41421 and go on. It doesn't follow any pattern. You cannot write this as a fraction at all. Another important number for GRE, pi 3, which is equal to 3.141 blah blah blah, right? These can't be expressed as fractions, right? So very simple definition for these two rational, irrational numbers, right? Good. Next we'll do how to compare decimal values. Comparing decimal values. Right. So numbers are pretty easy to compare. So let's say you have a 2 and you have, let me change colors first. So let's say you have a 2, you have a 3, you know 2 is greater than 3. Simple. Now if I put, let's say I compare 2 and 2.1. Well, I know 0.1 I put there, so basically 2.1 is actually greater than 2, so 2 is less than 2.1. What about numbers like these? So 1.83 and 1.823. So you have this decimal. Here you have 3 digits after decimal. Here you have 2 digits after decimal. Right? So how do you compare these where you have different numbers of decimals, of numbers after the decimal? So easiest way is to, where you have the less number of numbers after the decimal, you put a 0 to make up for the less, and then compare the number as if there was no decimal present. So you are basically comparing 1830 with 1823. So well, 1830 is bigger than 1823. So that's your comparison, right? Another example, 0.2139 comparing with 0.239. Again, you have 3 here, you have 4 here after the decimal. So to balance out, let's put a 0 here. Now take out the decimal. So you're comparing 2139 with 2390. So 2390 wins out, and that's better than 0.2139. Simple enough. Alright. One last thing in this comparison. So comparing fractions. Alright. So many times while comparing fractions, you'll have to use the calculator, right? But in some instances, you can do it quickly without the use of calculator, especially when the denominators are same. So here's an example, 11 over 15 and 9 over 15. Okay. So when the denominators are same, you only have to look at the numerator. So if the numerator is bigger, well, that number is bigger than any other number which has a less numerator than that one. Simple enough. And you can think about this again in the pizza terms. So here you're looking at 11 slices of pizza out of 15. Here you are looking at 9 slices of pizza out of 15. Obviously 11 slices win compared to 9 slices. Okay, so here you didn't have to use the calculator. But if you come across something like this, 11, 15, 13 over 19, here it's hard, like denominators are different. It's not that straightforward, so use a calculator. Alright, let's do some practice to apply the concepts we have learned. So here's a problem from the GRE, from the Barron's GRE book. So it's a quantitative comparison question. The common information that applies to both columns is given here, that 0 is less than x and x is less than y. Okay, so one thing we can know is that x and y are both positive. So in column A we have 1 over x minus 1 over y, whatever that value is, and column B we have 0. So for these ones, these type of questions where you have these symbols appearing, one easiest way is to pick values for x and y. So I know both x and y have to be greater than 0, but they have to be such that x is less than y. So let's look at the case where x is 2 and y is 3. So I'll have in column A 1 over 2 minus 1 over 3. 1 over 2 is 0.5. I know from my list of fractions that I should memorize. 1 over 3 is 0.333. And this value, whatever that comes out to be, has to be greater than 0 because 0.5 is greater than 0.333. So if this were the values of x and y, my answer would be A. But hold on, don't in a hurry answer A. Let's check another condition. So whenever you have this sort of condition where x and y are positive, one good set of values to look at is when x and y are between 0 and 1. So in this case, let's pick x to be 0.2 and y to be 0.3. So both of these are between 0 and 1. Between 0 and 1, very interesting things happen sometimes, many times actually. So it's always good to check that in quantitative comparison questions. So here you'll have 1 over 0.2 minus 1 over 0.3. If you plug this in the calculator, you would get 5 minus 1 over 0.2 is 5. 1 over 0.3 is about 3 point something. We don't need to be that exact. And 5 minus 3 would again give me something positive. Right? So again, the answer is A here. So seems like I've tested enough conditions. Both times I got A. Well, my answer is A. Another way to prove this, to prove that 1 over x minus 1 over y would always be greater than 0 is to look at it this way. So this is more like comparing inequality theorem. So if x is less than y, and if I take the reciprocal of both x and y, so I take 1 over x and 1 over y. Well, if x started out to be less than y, then when I do the reciprocal, the inequality flips. So now I'll actually have a greater than. So 1 over x would be greater than 1 over y. You should actually check this. This is only true though when both x, y are positive or both are negative. But it's an interesting rule to remember. Though not necessary, you can always quickly pick numbers and prove it to yourself. Actually, I would recommend here that you prove this reciprocality rule for yourself. Next, we'll look at simplifying fractions. We did do this slightly in the examples before, but now to properly look at these, so let's look at 4 over 8. Okay, another way I can write 4 over 8 is something like this: 4 times 1 over 4 times 2. So if I want to simplify this fraction, I can see that 4 is a common factor both in the numerator and in the denominator. So I can cancel out 4 like this, and what I'm left with is 1/2. Okay. So that's what we call simplifying a fraction. Now, you don't always have to go through this process where you write down the fraction and then end up there. Once you get better, you can do this in your head. So let's look at 12 over 18. So I know in both 12 and 18, 6 is a common factor. So 6 times 3 is 12. Oops, sorry. 6 times 2 is 12. 6 times 3 is 18. So this fraction comes out to be 2 over 3. that you probably need to know for GRE is factorials. Okay, so these are simple numbers that are followed by this exclamation point, 6 factorial. And what it represents is basically you take the product of 6 and all the integers less than 6 till 1. So 6 times 5 times 4 times 3 times 2 times 1. So all the factors less than the number, you take its product. And that is basically the definition of factorials. In this case, 6 factorial comes out to be 720. Right? Sometimes you'll have fractions with factorials. So like 6 factorial or 8 factorial. So in these cases, you can always simplify them, and which will save you a lot of time if you compared to using a calculator. So 6 factorial we know is 6 times 5 times 4 times 3 times 2 times 1 over 8 factorial is 8 times 7 times 6, and basically from here onwards it's actually 6 factorial. So 6 times 4 times blah 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 till 1, right? So entire this thing will cancel entire this thing, and you'll be only left with 8 over 7 in the denominator. So up top would be just 1, and at the bottom you'll have 8 times 7, which is 1 over 52. So see, without typing all these things in the calculator, you were able to simplify it and get to the answer. 8 over 7 is 56. Alright, moving on. Let's look at working with 10. So working with 10. 10 is actually a lovely number. It makes things very easy. So let's say you have a product involving 10. So maybe you have 1.35 times 10. So here, now we go to the calculator. What you have to do is basically move your decimal by one place to the right, and you'll get the answer, 13.5. Let's say you have 1.35 times 100. Well, move your decimal 2 times to the right, because it's 100 which has 2 zeros in here. Right? So you'll get 135. Decimal is over here, and you also put a 0 off your decimal, but you don't have to write that. You can just write 135. What about you multiply it by 1000, which has 3 zeros? So you move it 3 places to the right. So 1 place, 2 place, and well, you don't have any more digits. You still move it, and you'll place a 0 in there. So the way you will do it is 135. This 0 for the digit that was not present, and your decimal will be here, which again you don't need to write. Okay, so just digressing a bit here, it would be good to memorize some squares, some powers of 10. So 10 to the 1 is just 10. 10 square is 100. 10 cube is 1000. 10 to the 4 is 10,000. So memorize these powers of 10. They will come handy later on. Right, next, let's look at what happens when you divide by 10. So let's say we have 61.2 and we divide by 10. So when you multiply, you move to the right. When you divide, you move to the left. You make the number smaller. So with 10, you'll move 1 place to the right, to the left. So you'll get 6.12. Let's do 61.2 divided by 100. Well, now you move 2 places to the left. So you get 0.612. Let's divide by 1000. Well, you move 3 places. 1, 2. Again, you have no digits. Well, you'll just put a 0 there. So you'll end up with 0.0612. Right? Cool. Not too hard, right? Let's do an example problem on this. Alright, again, a quantitative comparison question. We have 3.7 times 10 to the 4 in column A, and a big number dividing by 10 cubed, which is 1000 that we just learned on your column B. Okay, again, 10 is a lovely number. We can just move the decimal around. 10 to the 4 means you have to move it 4 times. You're multiplying, you move it to the right 4 times. So 1, 2, well, no more digits, you'll just put zeros. So 3, 4, you'll have to put 3 digits, two zeros. So you'll get 3, 7, 5, 0, 0. Okay, so again, 1, 2, 3, 4. That's what you did. So you got 37,500. For this one, you're dividing by 1000, so 3 zeros. You don't see a decimal anywhere here, so basically a decimal is at the end. So now you'll have to move it 1, 2, 3 places to the left, so you get 37,500.0. So both columns are same, you get 0 for the answer. Easy enough, right? Alright, one more concept that we should know that involves that. That is the concept of scientific notation. Scientific notation. So whenever you have either very big numbers, so let's say 3, 5, 0, 0, 0, 0, 0, 0, or very small numbers like 0.000236. It's easier to represent them with tenths, just like we saw. So if you have big numbers, what you can do here, your decimal is at the end, well, you can move the decimal after the first digit. So what you will do, you'll move it 1, 2, 3, 4, 5, 6, 7. 7 decimal places. So you can write like 3.5, and the number of decimal places if you move, that will show up as the power of 7. Here the number was very big, you made it small, so the power is positive 7. Here in this case, where the number is very small, and you're going to move it 1, 2, 3, 4. 4 decimal places to the left, like this, 2.36, your power will become negative 4. So simple rule, when you have big numbers, you're making it small like this, you move the decimals to the left, you have a positive power. When you have small numbers, move the decimal to the right, you will have a negative power. So this is what is known as scientific notation. Next, we'll look at multiplying fractions. So let's say we have 1/3 and we want to multiply that with 2/3. Okay, so here what you do is basically you multiply the numerators with each other and you multiply the denominators with each other. So you have 1 times 2 over 3 times 3, and you get 2 over 9. Simple. Another scenario that you might see is, let's say you have a fraction with your regular integers at top and bottom, and you times it by something that has symbols. So let's say you have pi over 2. So again, in this case, you multiply the numerators, multiply the denominators. Denominator are simple. 2 times 2 will give you 4. In the numerator, 3 times pi, well, that will just give you 3 pi over 4. What about if you have a fraction times a number? Well, in this case, you just put a 1 in the denominator. 1 doesn't hurt anyone, and do the same thing. So 1 times 4 is 4 in the numerator. For the denominator, 3 times 1 gives you 3. Another scenario, let's say we have 2 over 9 times 24. Okay, again, I can put a 1 in the denominator here to make the second thing a fraction. Now here I can see that I can simplify 9 and 24. Both have 3 as a common factor. 3 times 3 is 9, and 3 times 8 is 24. So now I can simplify it. It will make my calculation a lot easier. For the numerator, I just have 2 times 8. For the denominator, I have just 3 times 1. And I get 16 over 3. Right, let's look at slightly more complicated examples. What happens when you have 3 fractions like these? 3 times 4, 3 over 4 times 8 over 9 times 15 over 16. So how about I simplify it like this? So I can say 8 times 1 is 8, and 8 times 2 is 16, right? And how about 3 times 3 is 9, and 3 times 5 is 15, right? So now, gathering my terms, for the numerator I have 3 times 1 times 5. For the denominator I have 4 times 3 times 2. Well, I see I can do one more simplification. I can take this 3 out and this 3 out. So now I'm left with 5 times 1 at the top, so 5. And at the bottom I left with 4 times 2, which is 8. So see, with these simplification you can do very complicated calculations simply without the use of a calculator. Alright, let's do an example that involves using these fractions, the multiplication of fractions. Alright. So here's one, a very typical GRE problem. So if 4/7 of the 350 sophomores at Monroe High School are girls, and 7/8 of them play on a team, how many sophomore girls do not play on a team? First of all, don't worry about what this word sophomore means. You don't need to. It just refers to some type of girls, anyways, or some type of people. The first thing it says 4/7 of the 350 sophomores at Monroe High School are girls. So let's do that calculation. 4/7 of 350 are girls. Alright. So whenever you see off like this, take it out, put a product sign. It means you're multiplying. Okay. Right. So we can do the multiplication rules we just learned. 7 times 1 and 7 times 50 would give me 350. So 4 times 50 is 200 girls. So 200 girls are at Monroe High School. Alright, now let's find out how many of these girls are on team. So girls on the team. So it says 7/8 of them. So 7/8 of the total number of girls of 200, right? Again, take out off to get a multiplication sign. 200, 8 times 1, 8 times 25 will give me 200, and 7 times 25 will give me 175. So I have 175 girls on the team. Let's see what the question is asking. How many sophomore girls do not play on the team? Okay, so always be careful. See what the question is actually asking. We don't want to know how many girls are playing on the team. We want to know how many are not playing on the team. So total is 200. 170 are on the team. So 25 are not on the team. And you enter 25 here. Okay. Alright, good. Now let's look at how can we add and subtract fractions. This is a bit more trickier than multiplying fractions, but still not that hard. So let's say we have 3/5 and we want to add that to 4/5. When denominators are same of your fraction, your addition or subtraction is very simple. You simply put the same denominator and you add the numerators, 3 plus 4, and you get your answer. Okay. The tricky part comes when your denominators are different. So let's say we have 3/5 and we want to add that to 1/4. So in this case, what actually we want to try to do is to get them to have the same denominator. And the easiest way to do is that basically you multiply each fraction by the denominator of the other fraction. So for 3/5, we'll multiply it by 4. So we'll multiply the numerator as well as the denominator of the first fraction by the denominator of the second fraction, which is 4. And we do the same thing for the second fraction. In this case, we multiply it by the denominator of the first fraction. Right? Now you'll see both of these, just to be consistent, let me write this as 4 times 5. So again, to clarify what I did, for the first fraction, I'm multiplying the numerator as well as the denominator by the denominator of the second fraction. And for the second fraction, I'm taking the denominator of the first fraction and multiplying the second fraction by that. Okay. So what this will end up doing is that you will have the same denominator in both fractions. 3 times 4 is 12, 5 times 4 is 20, plus 5 times 1 is 5, 4 times 5 is 20. And this would give me 17 over 20. Now, you would have probably seen a lot of ways to do these, to add, subtract fractions. This is just one of the ways. And if you're comfortable doing the way you are doing, you don't have to go through this. This, by the way, is also known as doing the common denominator. Okay. Sometimes this process is actually simpler. So let's look at a simpler process, simpler example. So let's say I have 1 over 4 and 1 over 12. Now I know 4 is a multiple of 12, or 12 is a multiple of 4. So I don't need to do anything with the second fraction, just the first fraction. How about I multiply top and bottom by 3? Well, there you go. You get the same denominator now, right? So whenever you see multiples of each other in the denominator, it gets simpler to add those fractions. So in this case, you get 4 over 12, which when I simplify, I'll get 1 over 3. Hopefully this makes sense. Let's do an example problem. Alright, Lindsay ate 1/3 of a cake. Alright, let's say Lindsay ate 1/3 and Emily ate 1/4 of it. Emily ate 1/4 of it. What fraction of the cake was still uneaten? So we want to find how much is left. So in these type of questions, the whole cake you can represent by 1. Okay, now Lindsay ate 1/3, so let's subtract that out. Emily ate 1/4, so let's subtract that out and find what we are left with. Okay, so this is what you want to calculate. To simplify this process, I'm going to first find the sum of 1/3 and 1/4. Okay, so here I have to do the common denominator here again. So the 3 and 4 are not multiples of each other, so simplest way is multiplying the denominators with the first and second fractions. So I'll multiply by 4 the first fraction, both the top and the bottom, so I'll get 4 over 12, and for the second one I'll multiply the top and bottom by 3, so I'll get 3 over 12, which is equal to 7/12, right? So this part is the part that's eaten, right? So now what I want to find, my whole is 1, I want to subtract the part that was eaten, 7/12. Now this calculation, never do common denominators here, okay? Whenever you're subtracting from 1, basically what's left is the parts that are not here. So think about the pizza. If someone ate 7 slices of 12 slices of a pizza, how many slices are left? 5. Well, that's your answer. You're left with 5 over 12. Okay, so this fraction, never do the common denominator. Do it in your head and get that out. You can always go and do this thing and find what it is, but not recommended. Okay, so your answer is 5 over 12. Alright, let's do a similar problem. So here Lindsay ate 1/3 of a cake. Alright, so Lindsay ate 1/3. Emily ate 1/4 of what was left. So Emily ate 1/4 of the left. Okay, so this is interesting. what fraction of the cake was still uneaten? Again, same thing asking, how much is left? So if Lindsay ate 1/3, how much is left? Well, it's what's left is 1 minus 1/3, which again you should never solve it by doing the common denominators. If 1/3 is gone, what's left is 2/3. Okay, again, pizza thing. If one slice is gone out of 3 slices, you're left with 2 slices out of 3 slices. Now the question says Emily ate 1/4 of the left. Well, this is the left part. 1/4 of left. So when I take out off, I put up multiplication. What's left is 2/3. Let's simplify this. 2 times 1, 2 times 2, and I'll have 1 over 2 times 3 is 6. Okay. So this is what Emily ate. Emily ate 1/6. Lindsay ate 1/3. Right. So now I want to find what's left, right? So I knew after Lindsay ate 2/3 was left, right? And Emily ate 1/6 of that. So let's find how much is left of this. I'm just going to subtract these two. So 3 and 6, the common denominator for that actually should come out to be 6, and you should try this yourself, that this would be 4 minus 1, which is 3/6, or 1/2. 1/2 of the cake is left. Right? So again, asking for the same thing but in a different way. Alright, one more question for your practice. So this one says, if 3/11ths of a number is 22, so it says 3/11ths of a number, let's say the number is x, is 22. What is 6/11ths of that number? So you want to find 6/11ths of x. Right? Let's think about it. So one way you always know what off stands for, right? So how about I take out off, put a product sign, and do this. Okay. So if I do the multiplication here, I get 3x over 11 equals 22. Right? Now to solve questions like these, what you can do is you can cross multiply like this. So the numerator on the left side with the denominator on the right side, numerator on the right side with the denominator on the left side. So you'll have 3x times 1 equals 22 times 11. So you get 3x equals 22 times 11, or x equals 22 times 11 over 3. Let's substitute that x over here. So I'll have 6 over 11. When I take out off, I have a product sign, and for x I'll plug in this value that I just found. 22 times 11 over 3. 11 and 11 cancel. 3 times 1, 3 times 2, and I'm left with 44. Okay. If you did this question this way, you did it wrong. Of course, I got the right answer, which is E, 44, but this is a very inefficient way to do this problem. And the reason being, so they tell you 3/11ths of a number is 22, and they want to ask me 6/11ths. Well, what's the relation between 3/11 and 6/11? Well, if I times 3/11 by 2, I get 6/11. So if I know 3/11 is 22, why not I just times 22 by 2, and I find what 6/11 is equal to. So see, if you had done this long way, you have wasted a minute of your time, whereas you could have done this thing in 10 seconds. So be aware and don't let GRE trick you. Right, that's all for the fractions section. for practice, do the exercise on page 263, and I did one of the questions in that exercise during these video lectures, right? So just to give you a heads up. Alright, I hope you enjoyed this lesson. I'll see you next time. Thanks, bye.